Hi, my name is Chris Boehner and this is Mark Bocello with FLIR. Today we're really excited to talk about the brand new cooled A-Series family of products. We have a near-infrared, 2 mid-wave cameras, and a long-wave camera we're going to talk to you about today.
Let's start by talking about the long-wave SLS camera. This is a 640 by 512 SLS long-wave sensor that goes all the way out past 9.5 micrometers. The reason why we're so excited about this SLS technology is it really hits the sweet spot for a lot of different applications. If you remember the legacy QUIP detectors, they really had great quantum efficiency, but pretty long integration times. If you remember the MCT cameras that are still pretty prevalent around the world, they had really not that great a uniformity, but fairly short integration times. The SLS technology really hits the best of both worlds. We've got good quantum efficiency, we've got great uniformity, and we've got super short integration times. For example, room temperature applications, you're really down to about 170 microseconds. So you think about stopping motion on anything that's spinning or moving fast or even thermally changing fairly quickly, being able to stop motion to characterize that thermally, sometimes you're only going to be able to do that with a sensor like this. Still, inside of our A-Series cooled package, just like our mid-wave and our near-IR camera, which means that you can stream digital data over gigabit Ethernet at 125 frames per second. You can take this sync input and use it for control over timing. So if you're going to trigger this to start acquisition based on an external event, or even synchronize frame capture or readout based on maybe a flash thermography system or something that you want to be able to pump into this, you can do it as well. Also, you've got video output, so the composite video gives you a nice analog feed that you can put up onto a monitor simultaneously. So still has all the benefits of our A-Series package, but again with this very exciting SLS technology.
Now I'd like to talk to you about the A6200SC. This camera features a 640 by 512 InGaAs detector, which is sensitive from 900 to 1700 nanometers. We also have an optional VisGaAs detector, which is sensitive from 400 to 1700 nanometers. Standard C-mount lens, and we can fit a filter holder behind there. But what's nice, and as Mark pointed out, is the camera physically is the same size, same mounting interfaces, and same back panel as the long wave he just spoke about. So we get the high speed, 125 frames per second, near-infrared SWIR imagery over gigabit Ethernet. We also have a sync input, so if we want to trigger it, trigger each frame or trigger to start acquiring data. And then we also have a video, composite video right here, NTSC or PAL, so we can get that data simultaneously. What's also nice about this camera, it works great for many applications such as solar cell inspection, so electroluminescence or non-destructive testing on solar cells. For art restoration, if you want to image through paint to see underdrawings. It also works great for laser beam profiling. Maybe I just want to unscrew the lens and shine the laser directly in on it. It's really sensitive in the near-infrared waveband, so much better than a CCD camera because it has better quantum efficiency and sensitivity within those bands. And additionally, that means you don't have to turn the laser up quite as much to get good readings.
So let's talk a little bit about the mid-wave, right? We talked about the long wave, we talked about the near-IR. These are both mid-wave cameras right here. We'll start with the A6700SC. This has been a flagship product for us, and for many reasons. Still 640 by 512, just like our other sensors right here. It is mid-wave, INSB, so we can cold filter it from 3 to 5 micron for thermal applications, or we can actually leave it broadband for applications that need to see reflected energy all the way down to 1.5 micron. So a lot of flexibility from that standpoint. Still the same packaging and housing that we talked about. However, we make this in a 50 variant. So A6750 means that we take it from a frame rate that's 60 frames per second on the A6700SC all the way up to 125 frames per second. So the applications that require high-speed thermal imaging, stopping motion on certain objects, things like that, we can achieve much better with the 50 variant. The 50 variant also adds this aux connector you see right here. The aux connector really offers additional flexibility over just the sync and trigger input as well as the video input. It's going to give us the option to do some iRig-B external sync.
So the sync, you can clock each frame, and then the trigger allows you to do like a start acquisition trigger, kind of like starting a race.
Absolutely. Yeah. The most exciting thing about this product is its price point. This price point is very, very attractive for a mid-wave INSB sensor. You want to tell us a little bit about the HD camera, Chris?
Yeah, so this is probably one of the more exciting out of the family of products. We took our 1280 by 720 high definition mid-wave detector and put it in a much smaller package than you normally used to seeing. We get that imagery, again, through very standard connectors, but we're doing 60 frames per second at the 1280 by 720 HD 14-bit data through CXP. CXP allows you to grab that data at the full 60 frames per second. Still has a video, but what's nice is this is an HD SDI video. So instead of just getting this NTSC video or composite video, you're getting that full HD video. So it's great if you're doing marketing videos or you just want to have really high resolution video that you can couple with the high-speed digital that you're grabbing through one of these two options. It does still have the same mounting interface, just slightly larger package. Now, something we didn't really talk about with the mid-wave detectors, we do have close-up optics. I don't know if you noticed we have a much larger optic on the camera right now. This is a 4X lens, and with the 4X lens, we can zoom in down to 3.5 micrometers per pixel spot size. So when you think about things like electronics inspection or maybe even that solar cell inspection we were talking about before, it's going to allow you to see and characterize that thermal differences. So as devices are getting faster and smaller in electronics, how do you measure temperature on that? How do you do your failure analysis? And this is one way to do it. Now, something we didn't really talk about on these that all the cameras have in the family is they're all GigiVision and GeniCam compliant. So what does that mean? Well, instead of using a FLIR SDK, you can use standard GigiVision and GeniCam commands to talk to the camera, control them, and grab the data. So now, without having to use any fancy SDK of ours, you can immediately interface to it. So let's say you're using MATLAB or National Instruments LabVIEW or maybe just your own C-based program. With standard snap and grab VIs, you can grab imagery from any of these cameras. Of course, they all come with our own researcher software.
That's a great point. Everything is compatible with our Research IR software. So we talked about the gigabit Ethernet interface. We also talked about the CXP interface. Everything has the ability to pump digital data, 14-bit digital data, into a laptop or a PC, anything running Windows with our Research IR4 software. Comes standard with all of our sensors, comes standard with all of our cameras, and it is really a true differentiator when you talk about looking at a true scientific camera, right? At some level, we've got a sensor pumping out data in all these different bands, but really what do we want to do with that data? We want to measure intensity, we want to measure temperature, we want to do radiometry, we want to be able to do true beam profiling, right? We can't do that with 8-bit data coming into a nice pretty monitor. We've got to take that digital data for real-time analysis. The guys in our Niceville engineering office have done an incredible job building these cameras and really building the researcher software up to something that is truly bulletproof and really answers the applications of all of the challenging needs of the world today. So we're very excited about it. We've got great demonstrations online. We really implore you to check them out as well. Is there anything else you'd like to talk about, Chris?
I think that's it. We're just really excited about the family of products that we're launching here and hope that you guys enjoy them as well.
Absolutely.
So you want to take some questions?
Yeah, let's do it.
Okay.
Sounds good.